Hi, everyone. So this is for our lesson 2, endless forms most beautiful. So these are key characteristics of quadratic functions. We're going to be this in a couple of days, for a couple of days, I should say. And if you take a notice here, remember this was our do now, and we talked about determining the slope and the y-intercept for each function, each linear function, because all of these make a straight line if you were to graph them. So if we reminded ourselves, remember it's y equals mx plus b, the number that's in front of the x, i.e. the coefficient, right? That is the slope, and then the number that's by itself, that's going to be your y-intercept. All right, so then if we took a look at this. So number one, we noticed that, so the number in front of x is that 3 right there. So that is going to be, actually probably color coordinate this. So that's going to be our slope, right? So which is m is equal to 3. Okay, and our y-intercept is, we're going to make that blue. Notice it's going to include the positive as well. So if we take a look at this, we're like, well, there's no number there. Then what do we do? And so I asked, well, 3x plus what will give you 3x again? And that what has to be not 1, right? Because 3x plus 1 is a different thing, right? But 3x plus 0 is 3x, right? So this is actually, when you see nothing there, it is a plus 0. Right? You could add nothing to anything, and it'll give you the same anything, right? Like 5 plus 0 is 5. 10 plus 0 is 5. Mrs. Lee plus 0 is 5. No, it's Mrs. Lee. I was wondering if you got that. All right, so again, so our y-intercept here is b, okay? And when we have something that looks like this, and we're like, we have parentheses, we're like, wait. Remember, we can just distribute that out, right? To get rid of the parentheses, and we get 1/2 x minus, and then 1/2 times 5 is just 2.5, or 5/2 if you want to say that. And again, our coefficient of x is the 1/2, so that's why our slope is 1/2. So it's, remember, up 1 and to the right 2. Right 2, is that right 2? This is my right 2, right? Your right 2. All right, and then your y-intercept is going to be this negative 2.5. So here's a negative 2.5. This is just a brief review, okay? And then again, right here, we notice, oh, 8/4. We're like, what? We just simplify that. 8 divided by 4, that's 2. So this is 2 right there. So that's why our slope is 2. And then, oh, wait, 1 second, I missed one. All right, do you see right here, we're going to take a look at number 3. Remember the number in front of x, you're like, well, there's no number in front of x. Oh, that must be a 0. No, that's not a 0. Why is that not a 0, right? Because remember, if we just have x, we're multiplying by something, right, to get x. If we put a 0 there, 0 times x is 0, not x. So we can't, when we're multiplying, we cannot have that be 0, right? So well, then what does it have to be then, right? And then we're like, well, something times x is equal to x, right? And that would have to be 1, right? Because 1 times x is x. So when we're adding, it has to be 0. When we're multiplying, it has to be 1. Multiplying and dividing, doesn't matter. All right, and so that's why we have that coefficient of 1. That's why we always say, oh, in front of the x is a 1. If we don't see it, it's not there, it's a 1. All right, so that's why our slope is 1. And then our y-intercept is going to be negative 2. Don't forget that minus right there. So it's that negative 2. Minus and negative, we're kind of swap that, okay? And then we have our slope. So we have a slope of 2. Remember, because we can just divide that. 8 divided by 4 is 2. And then our y-intercept is going to be 1. Now, for today, our learning target is identify the factored form and general form of an equation for a quadratic function. We're also going to be doing some, I should have been more clear, determine the absolute minimum and absolute maximum, and identify this point as a vertex. We didn't talk about vertex yet, but we will. Sorry. So we're going to move on. We've done these problems before in our previous lesson, the area of the dog enclosure. Remember, we had the dog enclosure with the storage on the right and the left, and then we did the handshake problem. Remember, where we're shaking hands with every single other person in that meeting? Well, that was the CIA people, right? And so it looked something like that. We were also going to do, but we did not get to, the pumpkin chunkin one and the ghost tour. But these are the equations that are already given to us, and plus it's graphed already for us. And we're like, okay, what do you notice? How do you know? Okay, and we noticed that there was all quadratics, right? All parabolas, right? That's what we call these curvy thingies, parabolas. Um, but the question was, well, okay, the first question is, well, how can you tell from the structure of the equation that it's a quadratic? And somebody said, well, I noticed that this exponent was all 2, right? Notice these were all exponents of 2, as opposed to, remember for our do now, it was just y equals mx plus b. There was no exponents in there, right? So when we have an exponent of 2, you know, oh, we're not in linear land anymore. We're in quadratic land, okay? We're going to be dealing with something that looks like this or like this, one or the other. Right. Another way to tell if it's looking like this right here on the bottom where there's parentheses, we have 2 variables, right? We have a t here and a t there, right? 2 t's, or 2 x's, or 2 whatever variable it is, okay? And that's another way that you could tell if we're in parabola land or quadratic land. And also, what does the structure of the equation tell you about the shape and characteristics of the graph, right? So notice that 3 of them are this way, which we call open down, because you know the opening is down, right? And one of them, the yellow one, is open up, right? So how do we know if it's open up or open down? Can we tell by just looking at the equation? And a lot of you guys did. Well, actually, somebody figured it out, right? So remember, in front of this form right here, there was this negative, and these were all negatives, right? And then only this one right here, the yellow one, was positive, right? So that's the thing that tells us, right? Whether it's positive or negative, whether it's open up or open down, okay? And so I did a little example here. So f of x equal to 3x squared plus 2, right? And well, we're like, well, what is that 3 gonna look? Okay, so the first number right here, the coefficient is 3, which is positive, which means it's going to open up, just like how this one was positive and it opened up, right? And so this is what we call A. A is, and you'll soon find out why. But if this number right here in front, right, if that coefficient is positive, right, then it's going to look like this, open up. Do you see? Open up. And then if it's negative, it's open down. I don't know if anybody smiles like that. Or not smile, frowns like that. That's kind of difficult, I think. But this is what my calculus teacher has showed me. I'm like, oh, I like that. And it really stuck in my brain, as you can see, still in my brain. All right, and so we are going to be talking about significant differences, but not right now. We're gonna skip this part. Okay, and then one thing here that once you get your book that you can highlight is another way to say open up is concave up, right? Because concavity doesn't have anything to do with your teeth. It has everything to do with your open up and open down. So another word, this is concavity. So con meaning with and cavity meaning plaque. I don't know. So open up means concave up. They're the same thing. So you will hear me say concave up or open up, and it means the same thing. Exactly the same thing, right? Same thing, open down, concave down. All right. And a graph that opens downward is identified as being concave down. So I would highlight those things. All right. Next one. So now we're learning 2 different forms. Okay, one is called the general form, i.e. standard form. I often say standard form because that's what I'm used to, but the book likes to use general form. Whichever one you use, I don't care. It doesn't matter, as long as you use it for the right one. Second one is factored form. So first one is standard form, and it's standard form because this is the standard way of writing this, right? So it's literally ax squared plus bx plus c, where a, b, and c are literally just numbers, okay? They can just be, it represents any kind of number, okay? And then this is where a does not equal 0. Well, why can a not equal 0? Because if a was 0, we would have 0x squared plus bx plus c. And then what would happen to our 0 times x squared? 0. So then all we have left is bx plus c. So this is now just linear, right? Because we have no more exponents. So that's why it cannot be 0, okay? So this is not a possibility, because then we're no longer in quadratic land. We're in linear land at that point, okay? That's where 0 takes us. And yeah, so this is what we call standard form or general form. Ooh, I should probably put a f of x there, i.e. y. It's the same thing as this. It's the y. Y equals f of x equals same thing, okay? So y is the same Just f of x is a different notation. It is called function notation, okay? And so we're going to be using this function notation quite often, okay? But you can think in your brain, oh, it's just y, okay? Don't say, oh, it's f times y. Oh, f is like another variable. No, okay, don't do that, okay? It's just a function. That's why it's f. Usually we use f, but it could literally be almost any other letter, right? There are a few letters it cannot be, but f is not one of them. So f of x, that's the quite typical function notation that we use. And factored form, and if you look at the factored form right here, notice it has parentheses, right? So, and it also has these R1 and R2, more officially known as R sub 1 and R sub 2, because it's a subscript, not a superscript. Sub meaning like the submarine goes down, right? So this is just to identify, well, something. But notice we have two R's. So how do you, if you have two R's, but they're supposed to be different, how do you tell the difference, right? Just like if we have two people with the same name, how do you tell the difference, right? You usually their last name, right? So this is like their last name. So it's R1 and R2, okay? R2, D2. All right, so this, and we'll figure out what that R means later on, okay, just not yet, okay? And this A, notice that they're using A here as well, and this A is actually the same value as this A, okay? So if you know what it is in standard form, in factored form, it'll have that same value here, okay? So we were going to just identify, oh, one more thing, leading coefficient. In standard form right here, the A is identified as a leading coefficient, and that leading coefficient tells us whether it's open up or open down, okay? So if A is positive, or the leading coefficient is positive, then it is going to be open up, which means that we're gonna have a minimum point right there, right? Because if it's open up, we have a lowest point, okay? And if it's open down, right, then we have the highest point, okay? And so if it's the highest point, we call that a maximum. All right, and we went back over here, scroll, and we're like, okay, let's identify them, right? If we looked right up here, we're like, okay, what form is this? And we're like, oh, well, I noticed that there's a square there, right? And I don't have any parentheses, so this is definitely standard form, okay? And this one has parentheses here, right? And we don't have any squares, but we have two parentheses, and we have two places where it has a variable in it. So this is factored form. Okay, I'm thinking out loud, so you can see. And again, right here, oh, I noticed, oh, there are parentheses around these. I have two parentheses and no like x squared or anything like that. This is factored form, right? And this one, oh, definitely have that square there. So, and this is all written out with no parentheses. That's general form, i.e. standard form. Okay, and notice right here that the A's, the numbers in front, right, are both the same. The -10, -10 here, -16, -16. See, I told you, right? And same thing with this one. We have the top part is going to be standard form, bottom one is factored form. Here, handshake problem, top one, standard form, i.e. general form, and the bottom one is factored form. Normally here, you wouldn't see the parentheses like that. It would look like this. So it would look like 1/2 n times n minus 1. Does that mean it's not in factored form? It is in factored form, okay? If you have 1 and we have an n on the outside with no, it's just, the reason why it doesn't have a parentheses is because there has no like plus anything, right? So that, like, if you notice, like right here, it has an x plus 10, and we want to multiply that whole x plus 10 with the other x minus 50, right? That's why we have them in parentheses, because remember, order of operation says we have to do parentheses first, and then because if we didn't have those parentheses, they would look completely different, right? So that's why we're including those parentheses in there. And you'll know later on why it's called factored form. Sometimes it's also known as the intercept form, the same. There's a reason for that. And I don't know if you notice the patterns. If you look at these guys right here and look at the graph and see, why is it called intercept form? There's a reason. I'm not going to tell you, no. It's a secret until tomorrow. Or actually, it's going to be a couple of days, maybe in a couple of weeks. All right, and so remember we talked about this when we said, okay, now looking at just the equation, can we figure out, does it have a min or a max, right? And here it says absolute min or absolute max because that's the absolute lowest it could go or the absolute highest it could go. And somebody had made notice, if you have a min, you're not going to have a max. Not for this one. We are later on going to get to graphs that look like this, where it has like different ones like this. And so we'll have like, oh, this is a max, that's a max, that's a min. Like we have a couple of different kinds, but this is not going to be that time where we do that. Okay, so for parabolas, we only have one min or one max. We do not have both. It's never going to happen. And you may wonder why. I'll talk about that soon. All right, so if we look at this one right here, so remember we looked at that leading coefficient of 2. We're like, oh, it's a positive, which means it opens up, which means if it opens up, is that a min or a max? We're like, oh, it's a minimum, right? I always get confused. That's why I have to draw it out, right? So that's a minimum. And then what is my minimum? I don't know. I just know that it has a minimum, right? That's all we're cared about right now. And so remember, this is a negative number right here. This is a -2. So negative means that it opens down, which means that we have a maximum, right? That's why somebody thought it was a min, but it's actually a maximum. And then same thing with this one. This one was it's a negative, so that is going to be a maximum. Again, this is negative, maximum. This is 1/3, so that's a positive number. So even if it's a small positive number, it doesn't matter, right? It's still going to be open up like this, and it's going to give us that minimum right there. And this one again is positive, even though, see how this one doesn't have that parentheses there? It normally doesn't, right? If you're not adding anything with the x. So it's going to be 2. We're just looking at the 2. We don't care about the x right now, just the 2. And that's going to be a minimum because it's positive, okay? Oh, and the reason why we only have one, so if we have, it looks like this, there's my max. Okay, what would be my minimum? How low does this go? Where like it has arrows, that means it goes on forever. Well, how low does that go? Well, to -infinity. So it technically goes to -infinity, right? Because it just keeps on going down, down, down. So that's why we don't have like an absolute minimum, because there is no absolute minimum. Because you can always go lower. There's no set number that it can be, right? But it does have a maximum. It has a maximum of whatever this height is, right? So if you look right here, let me scroll, sorry for your eyes. Close your eyes if you didn't like that. We'll open them now. So here we have a max at 320. And notice we're looking at the y value, right? Because we're talking about how high it is, and how high and how low is the y value, right? How left and how right, we don't care, right? So that is a max at 320. Here we have a max at 9,000, right? Because it's how high. So it's never going to get higher than 9,000. Like I'll bet you $5 million. If you can find me a point on this graph that's higher than 5,000 or 9,000, not 5,000, I would lose that bet then, higher than 9,000, right? Then, you know, but you literally, graphically, you can see, oh, it's never going to pass 9,000. Okay, 9,000 as high as it goes, right? And if you read about this problem, it's about getting the most profit, right? Depending on how much they're increasing or decreasing their the price of their tour. It's a ghost tour, right? So, and then this one right here was it has a maximum right here, and I forgot what that max, I think it was like 1225 or something like that, right? So max, we're just gonna pretend max at, or 1250, that would make more sense. 1250, right? And here it would have a min, and that's actually not at 0. It's actually at like -0.5 or something like that. But it's something very, very small. That's why you can't see it. If you were to zoom in, right? If you were to graph this, you can go on Desmos and graph this guy, and you can see what the minimum is. But the minimum is not 0. It's like the minimum is min at, I think it was like -0.5 or something like that. But we can't see it right here because it is not clear to the naked eye, right? Because our that's at like -5, right? Our units are very, very small, so we won't be able to see that. But yeah, that's how you determine mins and maxes. All right, and for your homework today, right? Oh, and we're gonna go over this next time, but for your homework today, we're gonna scroll down. Here we go. And it's definitely one of these, I don't remember. So if you go to your Canvas page right here, oh look, I'm on the Canvas page. How did I get here? I don't know, so let's find out. So if you go here, here's the Canvas page, you go all the way down, right? Go to Monday, endless forms. You're gonna, oh, learning targets again, right? Vocabulary words. We did not learn about second differences, but that's okay. We will get to them. And right here, oh, I'm gonna replace this video with that video. And here's the exit ticket for today. Try it out. Here, you're doing the right one, practice one, right number 1 and practice number 1. And then your answers, you can check your answers right here along with the homework reflection. So I'm just gonna go right here. So this is going to be, so we're doing this guy right here, and we're doing this guy right here. Okay, that's your homework. And if you're like, well, what was the homework answers? Just click on that. Come on. All right, here we go. And then you're going to click on this homework reflection form so that you can reflect on your homework and tell me what you got right or wrong. Okay, you don't need to tell me what you got right or wrong, but if you still have some questions, you're like, I still don't understand, right? And if you notice right here, there were some errors, so make sure you check that. Don't like read this and go, oh, it's wrong, because there were some mistakes on here, actually quite a few. So please make sure you read the corrections on that. All right? We'll talk to you later.